So first, introductions. So thank you so much for the introduction that you gave. Just a little bit about me. I'm currently working in cyber risk at LiveNation. I've worked at companies like HP and Asurion and Vanderbilt in the past. I did not have a traditional journey to tech. In data, I was first a biology student and just kind of along the way after being pre-med fell into data science and have loved it ever since. So I do have a little bit of research published in genomic medicine, but now a lot of my focus and passion is in natural language processing and artificial intelligence, which brings us here to today's project. So a little bit about the project's motivation as well. I mean, Twitter is such a large social media platform, and it has such a focus on community and knowledge sharing. I've had it for over 10 years, and I've now started to dedicate my account to providing tech and data resources. And so I thought that creating a bot that would tweet like me to my community could be really cool and help provide information when I'm just busy doing something else. So what is GPT-2? So y'all probably have been hearing about ChatGPT, and I'm going to get there in a second. But I actually used GPT-2 in this project, and this project was done the beginning of last year, 2022, a little bit at the end of 21. So this is before ChatGPT came out. But GPT-2 is a text generating network released by OpenAI in 2019 for the single purpose of predicting the next words in sentence. So you can think about it as completing sentences, predicting what that next word is going to be. It was trained on 40 gigabytes of text ranging across many subjects just around the entire internet. And it's very good at generating text. It can be improved by training on text specific to its application. So in this case, training it on my tweets to help it be very good at generating new tweets. And it uses a cool process called transfer learning, which is a machine learning method where the pre-trained model, you're reusing what you learned from one model in the next problem, in the new model, and all within one project. So it uses what the model has learned from a previous task with training data so that it now knows how to behave unsupervised without much data. So let's get into the GPT family history a little bit. So all of these belong to the same family of AI models. They're called transformers. So like I mentioned, that transfer learning, they're called transformers. And unlike previous generations of machine learning models, they are trained to solve more unified tasks. So they do not require pre-training for every specific task. So they're doing that transfer learning. They're learning very rapidly. And I mean, it takes a lot of data, but they can become very impressive. So what I used was GPT-2. This was created February 2019. It had 1.5 billion parameters, primarily used for text summarization and translation. Next, we got GPT-3, which came out June 2020, has 175 billion, 10 times as big as the GPT-2, and its purpose is for sequential text prediction. So it's going to complete sentences and generate responses on the fly. So GPT-2 was starting to kind of summarize what you already gave it, help create like new tweets or new rap lyrics or something based on what you've given it. But GPT-3 is kind of going a step further and really doing that sequential text prediction. And now ChatGPT was developed November 2022 and is that girl right now. And basically it's taken GPT-3 and just enhanced the capabilities. It's created a chat bot on top of GPT-3. So it's capable of generating human-like responses to text input to engage in natural language conversations. But all of this ChatGPT is really just built upon GPT-3, which was built upon GPT-2. So let's look at some of my methods of my project data used in my output. So for this project, I extracted my own tweets. So a little bit over 3,000 tweets using Twitter's API. Tons of processing was needed to remove retweets, usernames, links, punctuation, blanks, all types of stuff in the tweets. And then, sorry about that, that's a typo. But with the model, I fine-tuned the GPT-2. I used the 124 size model, which honestly is on the smaller end. I had to use Google Colab. I mean, if you've ever worked on these kind of projects, you know how frustrating it can be when it just keeps crashing on you. So I worked with a smaller size with model parameters, and I generated the deepfake tweets. So here's a little bit of my data, my own tweets. So you can see sometimes I might just tweet mood. I tweet a little bit about NLP. I love NLP. I talk about work, Karen's, different social things that come up. So these are my exact tweets. And after pre-processing over 3,000 tweets, I was left with 2,353 of my own after cleaning all that stuff out. And that's what I use in the model to generate new tweets. So let's get into GPT-2's model parameters just a little bit. On the right side, this is my exact code snippet of where I am generating those parameters. And some keys and quick things to kind of note with this is length. This is the number of characters that you want it to return back to you. So let's say you're doing something like rap lyrics or a poem. You may not, you may choose a smaller or larger size as this. I picked 140 because that was the max characters in tweets at that time. And temperature, I did around 90%, 0.09 temperature, and that controls the randomness of the predictions. So the higher the temperature, it can be more diverse, but it also can have more mistakes. Top K, I did 0, but the higher the K, the crazier the output. So I'm sorry. Oh, was that for me? No, okay. Top K is that y'all talking to me? No.
Oh, sorry, in the background, sorry.
Oh, okay. Top K, I went with 0, and basically the higher the K, the crazier the output. But I want this to be very true to me, sound like my exact, my legit tweets. So I went with 0. I didn't want to get crazy. And then top P, this is limits the generated guesses to a cumulative probability. So making it to where it's just probable that these are going to sound like me. If you're generating text that's maybe not as stuck to a person, but you just generally want a rap lyric. So you generally want something that sounds like Beethoven may have something similar to this, but I think you might could flex it and do a little different if you're doing like wanted to sound like Jay-Z or Kanye West or something. So here's some generated tweets, which I thought was so cool. Like it starts, even the first one, I decided to do an online portfolio project last night that I thought would help people land tech roles. Like, what? That's me. And then the last one, like, so now we know why Elon would be so passionate about AI. Like, that is me. So I just off the bat saw this and was like, OMG. Now, as you can see, there's a little bit of some grammatical kind of errors. And that really, I think, comes from when I pre-process my tweets. And that's one of the challenges I'm going to mention. But there's a lot of, emojis. They will come out as Unicode. And when I was processing the Unicode and using regex, it resulted in some of the just text getting a little chopped up. So I think that's why it looks this way. No hairstyles planned this week. I have hairstyle planned for the rest of my life. Like that is me. That's hilarious. That's on 20. This trip. So like these tweets, I just really instantly was like, oh my gosh, this is me. And let's get into some results in Outlook. So did a simple like common words analysis first off to see my real tweets and the GPT tweets. You can see boldly that tech is right there. That's something that was a common thread between them both, which was ultimately my mission in the first place. So I thought that was a great thing. Also, I did a topic modeling with NLP Spacey. Now, this is basically looking at a cosine similarity in a in the space, right? Like if you think about a coordinate plane or like the space and where these words fall and how these tweets from mine to the GP2, where do they fall? And so these are some of the topics. Now with topic modeling, you can choose a wide range of number of topics. You can do 10 topics, 5, 20, whatever. But I just stuck with 2 to keep it simple. And these are the topics that you kind of see sitting around. I did see in the GP2, I do tweet a lot about Tesla. That's honestly probably where they got the Elon from, because I tweet a lot about Tesla. Tweet a lot about Jenny's. I love Jenny's ice cream, shopping. So I'm seeing a lot of similarities in things I am interested in. And the similarity score was a 0.94, which is very, very good. But one of the cons of NLP Spacey and the way that they measure similarity, you can say that I love shopping or I do not love shopping, and they will have a high similarity because of where they're sitting in the plane, where they're really opposites. So in order to try to get at that, I did look at sentiment analysis as well, and the sentiments look really similar as well. So it's not like the tweets are using same words, but they're like on the contrary or flipped side of my tweets. The sentiments look almost identical. And lastly, Outlook. I mentioned the Unicode challenges and also the challenges of just running the model on Google Colab. And it can just be extensive, especially I tried originally to work with a larger GP2 model, like I want to say 335 size instead of what I ran with the 124. So that was just a big challenge. And next steps would be to further compare my tweets with GPT-2 using term document comparison, like other NLP tools for comparing text. Also connect this to Twitter API so I can start automating these tweets with to the Brittany bot account. And it would be cool to apply this with ChatGPT as well and see what type of tweets or, you know, sentences it comes up with that sounds like me. And here's tons of resources. I will share these slides for anyone that's interested. You can connect with me, email, GitHub. This is on my GitHub, like the code to this is on GitHub. Doesn't have a README yet, but it's on there. And LinkedIn, and I'm on Twitter, Instagram, and YouTube, Brittany City. Thank y'all.